Assalamu alaikum. This is the demonstration of our SAP 1 project. We are Team Red Hell. My name is Salman Saki Abir. My ID is 210021110. So now we are going to look at the ALU or Arithmetic Logic Unit part. So this is our ALU. Let's go to the child sheet. So our ALU takes 14 inputs and 6 outputs. So first two of them are EO and SU. So EO indicates whether there would be output from the ALU or not, and SU indicates if it would be addition operation or subtraction operation. So the next 6 inputs A0 to A5 are from accumulator register, and B0 to B5 are from B register. So for the operation we are using 474 LS83 ICs. They are full adder ICs. So they can each take 8 inputs, 4 from each A and B. So we're connecting the first 4 inputs A0 to A3 directly with the first IC, and A4 and A5 with the second IC, as you can see. So the B inputs are here. So B inputs are connected with the XOR gates, one end of the XOR gate, and the other end of the XOR gate are connected with SU, as you can see here. SU is connected with the XOR gates, and other end is connected with the each of the B inputs. So the reason it is done because the property of XOR gate, if one end is 0, then other end would always the same. So if A and B, there are two inputs. If B is 0, if A is 0, output would be 0. If A is 1, output would be 1. But if B is 1, then the A input would be toggled. So if B is 1, if A is 0, output would be 1. If A is 1, output would be 0. So that's why the SU is connected with the XOR gates. If SU is equal to 1, then the B inputs will be toggled, so it will perform the subtraction operation. If SU is 0, then it will just stay the same, so it will perform addition operation. So these are our full adder ICs. So there are 4 inputs, 4 sums from here and 2 sums from here, and the carry of end carry of this IC is connected with the CO, or the first carry of the second IC. So after the addition, there is another part. This part is for the 2's complement subtraction. So as we know, to subtract two numbers using 2's complement method, we need to first uh, take the complement of them first and add them. Then if there is a n carry, we'll have to uh, we'll have to toggle it again and add 1 with it. So that we are basically doing that here. We are complementing the output again and adding 1 if there is an carry. So if there is summation, then the output is the same, no change will happen. But if this is subtraction and there is an n carry, then we just need to take complement of it and add 1. So what is happening here, that we are taking the n carry of this one, so it is the last n carry. If it and we are taking another input from the SU, as you can see. So SU and its n carry, first it is not get and connected with the AND gate. So if n carry is 1, the not of it would be 0, so it will be 0. So after in the XOR gate, there will be no change. And here this gate it basically indicates whether there should be 1 added with the output or not. So if SU is 0, if C the n carry is 1 and SU is also 1, it will become 1, this output will become 1, and it will add 1 with the output or sum. So this one indicates whether there should be any toggling of or not. So as you can see, there is another set of XOR gates. If this output is 1, it will just toggle the sum. So, and this output is indicating the sign of the uh, end sum. So if it's 1, then it will indicate the sum is in minus form or minus sign. If it is 0, then it will indicate the sum is in plus sign. So as you can see, these sums are connected with the XOR gates. Other end is connected with this, and the outputs are connected with the LS, another set of 74 LS83 ICs. And then these sums are connected with the tri-state buffers, which will indicate whether there should be any output from ALU or not. As you can see, the control pin is connected with the EO, which comes from the accumulator sequencer. So, and then the outputs are O0 to O5. They are the final outputs.